Hello, myself Prashant Kumar Srivastava. I am physics teacher. Today I will teach about the vector quantities. What is the vector? A vector is a quantity which has both magnitude and direction. We will denote vector by a bold-faced letter or letter with an arrow over them. Thus the vector A may be denoted by A or as in figure. The magnitude or length of the vector is then denoted by mod PQ, mod A, mod of vector A or A. Okay. Vector quantity is a quantity which has magnitude and direction both, and also it follows the laws of vector, like laws of parallelogram, laws of triangle. There are different laws which is follows by the vector quantities. We introduce the concept of a vector as directed line segment PQ from one point P to the another point Q. Here P is called the initial point or origin of PQ, and Q is called the terminal point and or terminus of the vector. This is the representation of a vector. Q is known as the head and P is known as a tail. Scalar. A scalar is a quantity which has only magnitude but no direction, such as mass, length and temperature. It only measures the magnitude, like as example, suppose mass is 2 kg, then 2 kg is representing the magnitude. Vector algebra. There are two basic operations with vector: vector addition and scalar multiplication. First is the vector addition. Consider vector A and vector B. Picture in the figure, the sum or resultant of A and B is a vector formed by placing the initial point of B on the C terminal point of A and then joining the initial point of A to the terminal point of B, pictured in figure. The sum is written by C is equal to A plus B. This is the addition of vector. We always add the head of one vector to the tail of second vector. Now scalar multiplication. Let A be any vector and M be any given scalar. Then M into A denotes by the the length or modulus M into A is given by mod of MA is equal to mod of M into mod of A, or this is M into A. Okay, please 1 minute. Now this is the scalar multiplication. Again we know that laws of vector. Suppose A, B, C are vector and M and N are scalar, then the following laws: A plus B plus C is equal to A plus B plus C. This is the associative law for addition. There exists a zero vector such that for every vector A plus 0 is equal to 0 plus A is equal to vector A. For every A there exists a vector minus A such that A plus minus A or minus A plus A is equal to 0. Existence of negative. A plus B is equal to B plus A, commutative law for addition. M into A plus B is equal to MA plus MB, distributive law. M plus N into A, this is MA plus NA, distributive law. M into NA, this is MN into A, associative law. Then there are different laws which is applies in the vector algebra. It behave like as a algebra in mathematics. Unit vector. Unit vector are vector having unit length. Suppose A is any vector with length mod of A greater than 0, then unit vector A is equal to vector A upon mod of A is a unit vector. Null vector. A null vector is a vector whose module or magnitude is 0 and is denoted by 0. Mod of A is equal to 0. We define A as a 0 vector. Equal vector. Two vectors are equal if they have the same magnitude and direction. Collinear vector. Vector which have the same support are said to be collinear, and the line is known as the line of vector. Coplanar vector. A system of vectors is said to be coplanar if their supports are parallel to the same plane. Multiplication. Product of vector, dot or scalar product. The dot or scalar product of two vectors A and B denoted by A dot B and is defined as the product of the magnitude of A and B and the cosine of the angle between them. A dot B is equal to mod of A into mod of B cos theta. Mod of A means magnitude of vector A. Mod of B means magnitude of vector B. Theta is between 0 to pi. Proposition: suppose a, b, c are vector, m is a scalar, then the following laws hold. A dot b is equal to b dot a, commutative law for dot product. A dot b plus c is equal to a dot b plus a dot c, distributive law. M into a dot b is equal to m a dot b or a dot mb, or a dot b into m. I dot I, j dot j, k dot k is equal to 1, and I dot j, j dot k or k dot I is equal to 0. Means the dot product of same vector is 1 and the dot product of different vector is 0. Cross product: the cross product of vector a and b is a vector as follows. The magnitude of c is equal to a cross b is equal to the product of the magnitude of a and b and the sine of the angle between them. The direction of c is equal to a cross b is perpendicular to the plane of a and b, so that a, b, c form a right-handed system. In symbols, a cross b, vector a cross vector b is equal to mod of a into mod of b sine theta n cap. Theta is from 0 to pi, where n is a unit vector indicating the direction of a cross b. Proposition: suppose a, b, c are vector and m is a scalar. A cross b is equal to minus b cross a, commutative law. A cross b plus c is equal to a cross b plus a cross c, distributive law. M into a cross b, m a cross b or a cross m into b is equal to a cross b into m. I cross I, j cross j and k cross k is equal to 0. I cross j is equal to k, j cross k is equal to I and k cross I is equal to j. Triple product, but triple product is not in syllabus. This is the syllabus in the syllabus of mathematics. Dot or cross multiplication of three vector may produce a meaningful product called triple product of the form a dot b into c or a dot b cross c and a cross b cross c. A dot b cross c, b dot c cross a or c dot a cross b. A cross b cross c or a dot c into b minus a dot b into c. A cross b cross c, it means this is a dot c into b minus b dot c into a. This is the numericals related to the vector analysis. There are given two vector a and vector b. Find the angle between the vectors. Vector a is 3i plus 2j plus 6k and vector b is equal to 2i plus 4j minus 4k. Theta be the angle between them. Then a dot b is equal to ab cos theta. Then cos theta is equal to a dot b upon a into b. First of all, we calculate the magnitude of both vector, magnitude of a and magnitude of b. Then putting the value in the formula, then we are getting cos theta, this is minus 5 by 21. Problem number 2, find the sine of the angle between the vector I plus 2j plus 3k and 3i minus 4j plus 2k. So till theta be the angle between them. Then a cross b is equal to ab sine theta, then sine theta is equal to a cross b upon ab. First of all, we calculate the magnitude of both vector, and again a cross b, we calculate the a cross b by determinant method. This is the determinant: first row ijk, second row 1 2 3, third row 3 minus 4 2. We solving this determinant, then we are getting the a cross b. Again we calculate the magnitude of a cross b, this is root of 405. Then putting the value, we are getting sine theta. This is the problem number 3. So that the vector a 3i plus 2j minus 6k cap and b is equal to 4i cap minus 3j cap plus k cap are perpendicular to each other. Okay, we want to prove that both vectors are perpendicular to each other. Then a dot b, we are using the formula a dot b. If two vectors are perpendicular to each other, then a dot b is equal to 0. Okay, answer is 0. It means both vectors are perpendicular. Prove that any triangle sine a upon a is equal to sine b upon b is equal to sine c upon c. First of all, this is a plus b plus c is equal to 0. The sum of three sides is equal to 0. Take the cross product of a b c. A cross b plus c and b cross a plus b plus c and again c cross a plus b minus c. Then this is the result, and finally we divide this with abc. Then sine a upon a is equal to sine b upon b is equal to sine c upon c. Prove that a cross b, b cross c, c cross a is equal to abc to the whole square. A cross B dot into B cross C cross A, B cross C dot A minus into C minus B cross C dot C. Okay, we are solving this, then we are getting the result. This is ABC to the whole square. Finally, this is over, and this is the concept related to the vector analysis. If you have any doubt, any question, then you frequently ask in the comment box. Thank you so much. Myself Prashant Kumar Srivastava, and please like, subscribe my channel.